you want to go ahead and start with the intro, and I'll
Yeah,
catch up on
let's
this?
get going. It'll take a few
Yeah.
minutes to get started so that people can keep trickling in. So, all right, well, welcome everyone. Thanks for attending this meeting. Hope you're enjoying the rest of the meeting. It's been hard for me to get to most of it. I'm attending another one this week also, so it's been back and forth for me. But I'm Tim Meckel. I'm a senior research scientist at UT Austin. I work in the Bureau of Economic Geology. And together with Pat Hart and Sean Gulick and Sean Higgins, we wanted to convene this group to explore some ideas that relate to high resolution small source seismic, maybe have this interest group persist and have some discussions. So hopefully some of you saw communications earlier in the week about a survey that was sent out, and I challenge you to type that address, but if not, somebody can post it into the chat, and if you haven't filled it out, you will have an opportunity to do that as we go along. But we'll be talking about some of the summary of that topic of the survey toward the end of this. So we've scheduled, I guess, something around 2 hours. We'll have a break in the middle. And I will go through very briefly sort of a setup, and then we'll continue with the rest of the content. And this is meant to have a lot of discussion, so please feel free to either type some questions or comments into the chat and somebody can field them, or just do the other things like unmute yourself and speak up. So thanks for being here, though. Really appreciate it, and hopefully we can get some good discussion going. So the rationale for this is really to get that feedback from the community that's out there that is interested in this sort of a topic. So we're kind of probing the idea of establishing this national multi-user infrastructure consortium dedicated to high resolution marine seismics. We've previously sort of tossed around the idea that this might be called MASIC for Marine Seismic Imaging Center, but the name isn't that important. It's the participation that would be. So the idea was to get some content presented, because there was a sense that maybe people didn't entirely know or were aware of all of the different systems that are out there, what the capabilities were, what the current setup was. So we'll have some content presented from about 6 groups that have equipment currently. That's by no means everybody, but I think that'll be a good initiation. And then we know that there's already a complementary 2D system that Scripps provides for NSF. And so that's actually can be part of this discussion as well. So we're not limited to 2D or 3D in this discussion. We'll hopefully cover both topics. I think it helps to do a little bit of definition. So this was something that I think made sense to bring up here, which is for this discussion, we're going to sort of think of high resolution and low energy as anything that's sort of marine sub-bottom imaging. So we're thinking about towed CHIRPs and other sub-bottom profilers, single channel systems using boomers, mini sparklers, bubble guns, and air gun sources. Same thing with multi-channel systems. And also maybe the incorporation of streamer systems that are maybe anywhere from tens of meters to up to 1 kilometer in length, all doing 2D or 3D acquisitions. So this does not include the sort of water column and seafloor imaging system that you might be familiar with in some of the other systems. We're thinking mostly about sub-bottom imaging. So let's try and keep our discussion to those, although I know sometimes these other systems are integral to understanding everything the way we want to. So we're not ignoring them. We're just saying let's think about the subsurface and then bring those in as needed. For me, this diagram helps sort of put this in context. So just quickly, the lower horizontal axis is frequency. That more or less relates to sort of an upper horizontal axis, which is maybe your bin size or your pixel size of your final data set. And then the vertical axis is vertical resolution. And so you can see these different systems from optical in the upper right down to sort of the conventional 3D systems in the lower left all occupy sort of a different part of this spectrum. And so these two vertical gray lines just represent sort of what we would call the shallow soil or sediment studies that are in the shallow subsurface or subsea floor. So there's an overlap of systems obviously in here. And so we're thinking about frequencies in sort of the hundreds of hertz, maybe up into the 1,000 kilohertz range, maybe horizontal resolutions in the meters and vertical resolutions that could be anywhere from many meters down to maybe even decimeters or less. So a good way to kind of think about what resolutions we're targeting here. This is a table that has a lot of information, but really I just want to highlight kind of the three different subsets that are in the vertical and depth information on the right two columns. So those upper ones all in red are sort of in the 10 centimeters, tens to centimeters to maybe a meter vertical resolution. And you're usually imaging in terms of depth on tens of meters. And then there's this other sort of suite of technologies that are having a vertical resolution in sort of the multi-meter range, and they're investigating depths that are somewhere in the hundreds of meters subsea floor. And that can depend a lot on the energy of the source and design. So then there's the things we're very familiar with, like the length depth here at the bottom, which would be, you know, something nominally of kilometers of investigation, and maybe vertical resolution in the 5 to 10 meter range. And we all have our own personal experiences with these resolutions, but I think this kind of breaks out nicely into three categories. I work a lot with a P cable system that was built by Geometrics, so I'm kind of down here in the meters of vertical resolution and hundreds of meters of subsurface interrogation. And we can talk about other kinds of systems as well. So today's agenda, that was our introduction more or less. We're going to go into a series of very quick sort of lightning round 10-minute summaries of different systems that are out there. And you can see the list there in blue of the entities that will present. Again, this is by no means everything that's out there, but certainly will give us a good subset of initial discussion. And then we're going to have a short break if we have time. And then we're going to actually spend the last 45 minutes essentially going over the survey results and having some discussion about some paths forward. So any questions at this point before I turn it over to Sean to start with the Usgs systems? Okay, I will stop sharing and we'll take it from here. So Sean, hopefully you can share and continue on, and I will try and keep us to time.
Sounds great. Okay. All right. So I'm going to do a quick one. Let me share my screen.
So don't get insulted if I interrupt you. I'll have to interrupt myself too, I'm sure. So
no worries. Okay. And there. Everybody can see that? Okay,
yes.
Great. All right, so I'm just going to do a quick overview of some of the systems that we have at the University of Texas Institute for Geophysics, and I'm being specific about the part of UT because Tip Meckel is going to speak about the systems that are at the Bureau of Economic Geology slightly later. And a big, I just want to highlight that we have three marine technicians, Marcy Davis, Dan Duncan, and Stefan Sostrup, that really make all this work. And just a quick note of who UTIG is. UTIG was originally actually founded by Doc Ewing post-Lamont in 1972 down in Galveston. It was called the Galveston Geophysical Laboratory before it moved up to Austin where it is now. And we're actually parked right next to the Bureau of Economic Geology currently on the research campus in Austin. And all of our equipment is actually in Austin for those who are thinking about where you ship from and things like that. We do all kinds of expeditionary scale science there, but we have a whole suite of techniques and technologies, and very much are interested in people who would be interested in using some of this equipment, so it doesn't necessarily sit on the shelf, and we have some technicians that can go with it where that is definitely needed. And I'm just going to highlight the high-res systems that we have. So our primary seismic system we have is basically a 2D high-res system. We have two different 24-channel streamers that are actually made by companies that no longer exist. but they're not the Sercel solid state. They're actually gel-filled streamers. We have two different kinds of air guns. We have a Sercel Mini GI and a mini bolt gun from 1 to 20 cubic inches, and the Sercel is either in the 15-15 or 30-30 mode, or can actually be fired as a single air gun. Top right is the mini bolt, and bottom right is the mini GI. We have several different compressors. We've got 25 and 11 SCFM compressors. We have two of the latter. These are all electrical compressors. The 25 one requires 3-phase power on the ship, and the other ones are single-phase 220. And then we also have ways to bank the air, which turns out to be really useful in these high-res situations, as well as, of course, firing controller, a marine geode, and so on and so forth. So some quick shots of the system in action. So here's the big max air. And this is one of our sort of, if you will, an air battery. We use 4 individual tanks. We also have one smaller, even more portable tank that lets you keep firing while this tries to keep up with the use rate. And just an example of seismic acquisition on laptops, hotshot to fire them, marine geo to record, and some field shots, this being deployed off New Caledonia, for instance. And just a quick examples of the kind of data that this system collects. So this is, on the flank of New Caledonia. This is in a fjord in Alaska. So quite high resolution. Nominally, depending on the source, we're sort of in the 1 meter range, something like that, and sometimes a little bit coarser than that. We also have multiple CHIRP systems. And multiple different ways to collect the data. So we have both a 512i, which is the bigger from 0.5 kilohertz to 12 kilohertz, and a 216 from 2 kilohertz to 16 kilohertz, 4 and 2 transducers. We have both the old school big topside for the big unit, as well as a small portable topside for the little unit, and we have a marine winch that can tow and communicate with especially if you're going to deep tow the big CHIRP. So those are our basic systems. Just a quick shot of the examples of some of the data. So here's envelope CHIRP, and then full waveform version of the envelope CHIRP versus the 2D high res example of that we have. And I just wanted to do a quick shout out. We actually recently have written a best practices paper for CHIRP processing that I know we've been sharing with the USGS and others. But for those who are interested, you can grab it right off ResearchGate. If you just Google best practices for CHIRP, you'll find it. And just some examples of the kind of cleanup that we've been working with using just conventional seismic processing techniques, but not black boxing it anymore, but trying to actually get us some better images where possible. And one other quick note, we obviously have a bunch of other sonar systems and things like that we're not highlighting today. But at UTIG, we actually teach or UT in general, we teach actually a marine geology and geophysics field course where the students can go out and use all these data. And so it'd actually be interesting hearing others who are trying to get students into the field and do sort of, the hands-on classroom field work, interpretive processing things. And I just have a few pictures in the last couple of minutes here of the students in the field, kind of learning how to deploy the various kinds of these systems. And acquire the data, in real time. There's the CHIRP and the seismic being acquired side by side on the same ship, which is always cool, and doing some ground truth. And then also the same thing on the small boat that we use. And then teaching the students how to do it in the lab. So anyway, that's all I wanted to really show people is we have these systems. They are available for people to work with. We have a cost center associated with all of these systems, and very often we'll have our technicians go with the systems to provide the support, but we've also had agreements, like we've done it with the USGS and others, to actually just do an MOU and loan the systems out. So anyway, those are what's available at UTIG. All right, I think I'm actually ahead of time. Any questions?
Yeah, thanks for that, Sean.
Sure.
Any questions for Sean before we move to other systems?
Any questions?
Sean, do each of your components have their own sort of I guess it would be sort of a partition day rate, or how do you handle
Yeah,
your?
so the whole seismic partition is one partition, right?
Mhm.
And then the CHIRP partition is a separate partition. Those are two different day rates. Our small boat has its own partition for those who want to use it to, say, tow the small CHIRP or things like that. And then each of the other sonar systems each have their own as well. So each one of those has a separate day rate, basically. Any questions from anybody?
I have a question. Are those
Yeah.
day rate published on the website, or do you
No,
have to
because they're not officially on the website because we go through a negotiating thing with UT every year, right? And so we didn't want to have the wrong information out there. So in the end, we renegotiate and just reach out. It's under, you can find the whole system description under ig.utexas.edu/facilities.
Okay.
And then just reach out to me as the primary contact.
Okay, so there is a contact person right now that needs to be contacted in order to get the day rate.
That's right. That's right.
Okay.
Yep.
Thanks.
Absolutely.
Okay, well, I think our next speaker was going to be Jared Plushman from USGS in cooperation with Jenny McGee, and they were going to talk a little bit about their systems. So take it away.
All right, let me bring up the slides, Jenny.
My government computer is so secure that I can't share a few slides with you guys, so Jared's helping me out.
Yeah, does that work? Everyone see it?
Yes, looks great.
Okay, cool. So yeah, I was just going to go over a little bit about what we've got at USGS to give everybody an idea. I did not include in this our CHIRP inventory, so that's not going to be on here, but we do have quite an array and have just acquired some new ones of the new, we have a new 516 and a new, well, we're calling it the super mini CHIRP, but the new smaller EdgeTech CHIRP. And so we're kind of getting to use those for the first time. So we do have a CHIRP inventory that wasn't included on this, but it is there. So
and it's worth mentioning the 516 is a bit of a prototype built by EdgeTech that has some pretty neat bells and whistles, and it's collecting some pretty cool data the few times it's been used so far.
all right. So I was going to mention that in case everyone's not familiar, USGS has 3 marine science centers that sort of cover the states. We in Santa Cruz, in general, handle, the West Coast, including the Arctic and American Samoa and Hawaii and all that. Our Woods Hole office generally handles the East Coast, and St. Pete does stuff in the Gulf, but we do all work pretty close together and send techs and equipment back and forth. So for the purposes of this, I've included a pretty general inventory of what all of us have. So this when you see the list, the different things are kind of spread around, and that could benefit you or not, depending on where you are and where you want them to go. So, okay, next slide. Yeah, so I just broke it down. I didn't get into the real nitty gritty of, every little spec and detail and serial number, but we've got, a set of sources, and I included in here air guns, sparkers and boomers, and then our acquisition side of things. Our streamers, we've just gotten into the birds. We've got a few of those now, and we've upgraded some of our winches recently to handle our streamers getting longer and longer, and the hand deployments getting more and more exciting, and tech's getting older and backs getting sadder. So yeah, these pictures probably look familiar to most of you. So next slide, sources. So what we've got for sources now are, we have one GI gun, the 210. We've got 2 mini GI guns, and then the hotshot controllers to run them. So right now we've got the little portable one that, like, you guys have at UTIG, and we've shared those back and forth before, the little Pelican case guy. And then we also just got the rack mount controllers, so we can now run a 4-gun survey if we wanted to. But again, we don't have 4 guns, so part of the reason we're here. Every time we've run 4 guns, it's because we borrowed it from some of you. And then we've got, we have a small max air compressor, similar to exactly like UTIGs actually, to run the smaller stuff, and then all the things that go along with that, the umbilicals and manifolds and all that stuff. Okay. For sparkers, we've got a couple Delta sparkers, so the bigger 6 kJ, I believe. And then this is a picture of the mini sparker, and that's what we use quite a bit of. You can do it off any little boat anywhere, and the associated power supplies to run those. Although it sounds like those might be getting more regulated. So so this is our boomer. Next slide. Our boomers. So I looked into this and I actually had to educate myself on boomers because I haven't ever really worked with them. We've got a whole suite between the centers of single plate boomers that can be stacked up to make different arrays. But they're spread over the centers. We've got a few. The East Coast has a few, and then St. Pete also has a bubble gun, which I've never used, but it looks like a boomer to me. Maybe you guys are more familiar with it. Maybe it's the FSI equipment. So they've got one of those that they're adding to the inventory, and again, all the stuff to run those. Then on the acquisition side of things, this is our streamer sort of inventory. And again, this is a combined inventory of the East Coast and West Coast. But we've combined them on several cruises in cooperation, so they all work together pretty well. And like I said, that picture in the picture there is that's the East Coast, the Woods Hole's new big streamer reels. They can carry quite a bit on that. Then I forget what's next. Oh, that's it. Okay. Yeah. So like I said, we've got the winches to run those streamers. We have had previous collaborations with a lot of you. Like you said, we've borrowed guns from Lamont. We've worked with Scripps with, getting their techs and all their equipment on board and putting all of our equipment together. And that's worked really well. And I've shared back and forth with you, Sean and Stefan, our hotshots and miniguns. So there is a precedent here, and for, USGS's part, it's always worked out. And hopefully we've been able to give back as much as we've borrowed, but we've really appreciated, those relationships and all that help. Right now, the USGS stance on this is that we do want USGS science collaboration in order for us to contribute gear. So whether that, it depends sort of on the gear, what gear is loanable and what gear needs to come with a technician, obviously, depending on its level of, complication and expense and all that. But if there's data that a USGS scientist is interested in, even if they're not necessarily the chief scientist, that's something that we could consider and I think is negotiable. Yeah, the person to contact, I guess I should put that on here for this, is Tim Elfers is the head of our marine facility. I can put his name and email maybe in the chat. So if anybody was interested in learning more, and then he could, depending on which thing you were interested, he can steer you in the right direction for who knows the most about it. You asked, Sean, about any classes or anything. Because we're not a university or an institute, we don't really have much of a field class like that set up. It's sort of all on the job training. That being said, I don't know that we wouldn't be happy to be part of that or help out with that. I think that benefits everybody, to more people that know about this stuff and learn how to use it, and I think that's good. So
I can speak a little bit to the processing stuff as well, if you want, Jenny.
Yeah, I'm done. So yeah, take it away, Jared, with whatever you want to fill in there.
So we've spent, first of all, we spent a lot of time the past few years dealing with sparkers, for better or worse. A lot of it has to do with the regulatory issues along with air guns. And so we've spent a lot of time properly basically characterizing the source. So now when we collect sparker data, we're using shot phones and doing deterministic deconvolution and that sort of thing. So, this is kind of a representative image of what we can start with, which would be on the left, and then what we can end with, which is kind of the true high resolution component of what the sparker can do. And so we've got a system set up where we tow high frequency phones below it and use that in our processing. And, we use echoes, we use shearwater reveal, and we also deal with 3D seismic data as well. So we have software packages that, handle all this as well. So we're going to just share that as and I think this is from a paper. I was going to see if I had a schematic of the towed system somewhere in here. Let's see. Yeah, so it's evolved. This was like an early iteration of it, but now we've got a system where we basically, we don't have to worry about this with air guns because it's a nice minimum phase source. It's repeatable. With the sparkers, it's it can be kind of difficult. So, well, I think we finished on time.
Great. Any questions or comments for the USGS group? I have one. Jared, did you say that the processing stuff that you've worked up is now distributable?
Yeah, so a good portion of that was published in a paper, which I'm happy to send around to folks for the Sparker. And then we're working on kind of a follow-up paper right now that kind of lays out what to do on the acquisition side as well, more so in the processing, to get that kind of true broadband component of the Sparker. So I'm happy to send that to the group.
I'd like to ask if at some point we can hear a little bit about the regulatory framework and what you all are doing to enable permitting, particularly in state waters, and how other institutions can make use of your expertise and arrangements. But maybe that's a time scheduled for that later. Thank you.
Well, we have a section where we're talking about various obstacles. It might actually go well in that section in the second.
Thanks, Sean.
Yeah.
Anything else right now? We'll have plenty of time, I think, but if you've got something that's specific to anything that was just presented, feel free to ask. Okay, now let's keep rolling, and I'll be up next. So let me share that and go into seeing this.
Yeah, looks good.
Okay, so I'm going to cover the high-res 3D system that we operate at the Bureau of Economic Geology. You may have heard these kinds of systems referred to as P-cable or other. I kind of just generally use the term HR-3D. P-cable is kind of a patented technology. The company doesn't exist anymore. It was bought by Geometrics, but high-res 3D is probably the best way to refer to these technologies, because as you'll see, they're not one thing. They can be a hybrid of many things. And I've worked on this with UTIG and a vessel here in the Gulf of Mexico that Sean mentioned on his field course from TDI Brooks. So we're using vessels of opportunity for a lot of our work. I'm funded mostly through the National Energy Technology Lab, so I'm actually a DOE guy, so to speak. So I'm a bit of a fish out of water in this community, but I think there's a lot of synergies. So just to give you a sense of how these HR-3D technologies developed, and P-cable in specific, it's really not that new a technology at this point. They were concept testing this 20 years ago, and then gradually built some prototypes, and this was all done in Norway. And they eventually got to, in about 5 or 6 years, they were able to get to some pretty high quality acquisition, showing recovery better than 3D. And then they actually established the company and proceeded with some commercial acquisitions. You'll see through the early 2010s, there was a lot of acquisition in Norway. And then there was actually a survey that was done out in California related to the nuclear facility there for re-permitting it. And then we came along, at least in our system, in this sort of 2012 to 14 timeframe. So since then, a lot has happened. I haven't really updated this slide. There's some commercial systems that are very similar out there. NCS operates one in the Gulf, WGP in the EU. And you'll see there's kind of about 6 systems globally. This map's again out of date, but you see a lot of surveys in Norway where this technology was developed. And so that's kind of the history of it. Our system is I would call it sort of version 0. We bought one of the early systems from Geometrics. So it's a 12-streamer system. We ended up using a lot of support to help get us going on this. We hadn't done it before, so we were using a lot of additional support. I think we've now collapsed that down to a very tidy amount of support that's needed. So actually, we don't think probably you have to involve so many people now. Our system in detail looks something like this at full deployment. So 12 short 25-meter streamers, 8 channels. You've maybe got 175 meter spread. Your CDPs are maybe covering about 85 meters. And you're doing a lot of the positioning with GPS that are out on the ends of your cross cable, and then using some tail compass data that comes from the back of some of the streamers. And you're towing this down with paravanes down at about 2-3 meter towing depth, ideally. And that can be adjusted with weighting, but it's typically it's a pretty challenging to get it stable, but once it is, it usually runs very, very well. So our system, we've operated it in very shallow water depths, 10 to 15 meters even, but a lot of the other examples globally come from much deeper systems, out kilometer of water, et cetera. So it's not really a water depth dependent kind of system. It is a very short offset system, so think about it that way. We're usually going at the same rates and the same kinds of specs that you can see here as you might expect. We operate 3 to 10 GI guns. We've done it 2 simultaneously previously. We've generally collapsed back down to 1, and we're actually finding that the higher frequency sources are oftentimes can be just as good as some of the higher energy sources. So that's a lot of interesting things to explore. We're typically in about the 150 hertz dominant frequency. We're using solid GeoEO streamers, which helps with the permitting. They're not oil filled. We don't have any ITAR restrictions, so we can take this system internationally, and we've done that. I'll show you a quick example. We usually in the past have used third-party positioning to help, the navigation to help, but we think we're overcoming that now, and that's also a subject of we can talk more about. I mentioned we were using a vessel of opportunity, the Brooks McCall. It's about a 50-meter length vessel A-frame, and so it was suitable for what we were trying to do. Once you get the full system on board, it includes 5 winches, some of which are seen here, 2 winches on the upper deck, 3 at the bottom, two large paravanes, and then our source situation. So that's everything after about 2.5 days of mobilization. And then from there, you can get into deployment that takes anywhere from about 2 to maybe 3 hours. And if you can run 24 hours, that's helpful. If you have to pull it all in, that's a consideration. We don't really see any unique HSE considerations. It's the same general stuff, high tensions, pressures, electricity, deck wash, all that kind of stuff. The paravanes are pretty challenging, I will say. You'll see this picture in the lower right. Deploying large paravanes is an art as much as it is a science. So that's probably one of the more complicated aspects of deploying the system. The survey statistics we've done with 24-hour operations, we've intended to have rather large crews, 27 people, 5 scientists, 6 support. That includes all the navigators and the guns and compressor maintenance people, 3 MMOs for 24-hour observation, and then 13 crew. I know that we can now do this with almost half as many people from my most recent trip, so it doesn't always have to be such a large operation. 2 to 3 day mobilization, 2 to 3 hour deployment and recovery. We got about 5 to 7 square kilometers a day. Okay, Some challenges that are out there. Receiver positioning is a big deal. High resolution requires great positioning, so we can talk more about this. There's lots of research methods ongoing. In these systems, signal leakage is a real issue, and troubleshooting it can be a big challenge. So we've had our own trials and tribulations on this. There are newer generation technologies that eliminate that, or at least make troubleshooting it easier. Optimizing the geometry is actually something that's important. Looking at that cross-cable geometry and understanding what it's looking like in the water is important. I'm probably running out of time. I'll just show you some examples where this 150 hertz data is getting quite a nice imaging on the shallow interval. We get a 3D data set here on the inner shelf of Texas, where we've got a nice shallow salt dome. We see incised fluvial channels, and this was all published in interpretation many years ago. We did find fluid anomalies in these data, and we were able to put geologic context to those fluid anomalies. So those kinds of topics you can explore. All kinds of amazing geology to see here in the shallow interval, as you might expect in a quaternary section of a passive margin. We get lots of great channelization features, and etc. This was actually a little well platform that we had to go around here in this gap, so that shows you can operate around some infrastructure. I did take the system to Japan, where we participated in a project that had some pretty extreme monitoring. And we were able to run a 4-streamer system here because we had to bring it in and out every night and every morning. So we ran a 4-streamer system. It worked really well. It was incredibly stable. We used tail buoys to position with. That was new to me, but we really liked it. And we liked it well enough that I convinced Sean and his colleagues at UTIG to help us develop our own. So we're now doing that. So this gives you a sense of some of the acquisition you can do in about a 5-day period. For context, processing is really interesting. In an academic environment, we can bounce between different software packages for processing. This is just one workflow that we went through on that Japanese data set that kind of came in and out of different packages, both commercial and open. Again, nice data, really high quality data can be acquired. My colleague Sergey Fomel and his students have worked on merging these data sets, so you can actually merge high-res 3D and conventional data. He published that in Geophysics, if you want to have a look at that. This is some commercial data that NCS collected, really beautiful stuff out on the slope, all kinds of things to see in here. You can see their deghosting techniques tend to boost the frequency in the very highest and the lowest end. So really interesting possibilities with this kind of data. So I think I've gone long. So I'll just end by saying that we did develop some tail buoys. We're trying to test them right now. And I think these are all the different kinds of not exclusively, but different kinds of things we can work on with these kinds of systems. So if these are of interest, our system's in a service center like the others and can be used by external people, although we do like to also include our personnel just for insurance reasons. Okay, so that's what I had.
Excellent. Any quick questions for Tip before we move to the next person?
Tip, I was going to ask, what's the minimum size vessel you need for the full P cable system?
I probably wouldn't run it on anything smaller than that TDI ship I was on for the full, I think it was 30 meters. And that's because the A-frame needs to be able to sustain large out of plane tensions because the paravanes are pulling on it so much. You can obviously go bigger, but I wouldn't go a lot smaller. Although the four streamer system, you could go very small. Actually, we used a big ship in Japan, but I could see doing that on an incredibly small vessel if you had the sort of the booming correct to get your outer streamers out there. We're going to keep testing this for some projects that are coming up as soon as we can get back on the water.
Yeah, we're going to test it on a small crew boat actually, see if it'll work.
Cool.
Okay, the next up is Lee Elliott with the script systems.
Hello, everyone. Did I get this correct?
Looking good.
Great, thank you. So yeah, I'm Lee Elliott with Scripps Institution of Oceanography. Just giving you an overview of the portable MCS system that we've been operating. So some of the core components is, we have in our streamer, we kind of have two vintages of streamer right now. We have a 48, in 2005, NSF funded a 48 channel, 12.5 meter group spacing streamer. It was silicone oil filled. And so recently, in the past several years, we've been recapitalizing it. I've been writing proposals to recapitalize that. Now we've got a 96 channel, and we have some few spare sections. We're trying to acquire spare sections wherever I can. And a 96 channel went to 6.25 meter group spacing, so I could take advantage of higher frequency, higher resolution projects. We have 5011 birds. I believe I have a spare as well. Sound source, we've recently increased from 3 to 4 GI 210s. We can support multiple of the different configurations, 75-75, 45-45. Typically we do a lot of 45-105 true GI. And we have coupled some of these together, the 48 channel with the 12.5 with the 6.25 to do some projects. But that older streamer, some of those components are really starting to fail on us. Some of it can be refurbished, some of it not. We do send protected species mitigation equipment with this, so we'll contract for the mitigation, but we have the equipment. So we have 2 sets of big eyes, night vision devices. Actually, the night vision devices are the only ITAR controlled stuff that we have now. So I do have to get an ITAR permit for the night vision devices. Data acquisition system. So we have now 2 hotshot USB versions. And I'll show some other pictures of the computer racks, but that's the source controller. Navigation, we're doing a real-time brute stack. So we try to set things up so we can set this up on the ship pretty quickly. Then we also have we've recently been going to VMware. So we just have 2 computers, and then we run everything as a virtual machine. And that's so that we can it's easier for the engineers and technicians to administer these systems. It's a lot more compact. So we've spent some time in the recent few years in getting these, tuning our acquisition system to be more internal. So everything's a lot more pre-wired. So we're just running between the displays and the 2 small computer racks that we can spin things up pretty quickly. And so recently we invested in Radix Pro for the real-time data. So it's an overview of just the real-time product that we've been able to offer. And that's about the extent of the processing. We're like geared to support data processing, but we want to do real-time quality assessment and be able to provide users with as much real-time displays as we possibly can support. It's a recent cruise track, a recent cruise. We do a lot of international work historically with the system since 2005 and onward. This one was a return shipment from Namibia, so we do deal with a lot of international logistics, and a lot of the crews have been IODP, NSF funded IODP site surveys has been the majority. There's been other work for sure, but that has been the most of our cruises have been for that purpose. Here's an example setup on the, this was on the Atlantis. We had similar setup on the Thompson. More recently, with this one was a setup where we had we were doing two different streamer configurations. You can see the gray machinery off to the right. Those are rental compressors. So we don't own any compressors. So we own the acquisition gear, the sound sources, the receivers, but we do not currently own compressors. So rental compressors have been a real pinch point for us. We've been very successful, but it's been through a lot of effort in setting it all up and then carrying it out. So that's been a recent focus for us. This is a list of ships that we've taken the system or components of this system on. So we have worked off smaller vessels, larger vessels, so that some of it's been different configurations. I want to talk a little bit about rental compressors and our experience. These are some of the challenges. I'm not going to go through all of these, but we've had considerable challenges with rental compressors. It's unknown. What problems at sea. So as a result, we have been proposing to acquire portable compressors, and we've developed some criteria that we've used. And so there's mostly centered around supporting GI guns. We got to go diesel driven to be able to have a broad range of ships. We want long-term support, contract availability, compact footprint. We need to be able to get these on smaller vessels. We need to be able to deal with the environmental issues. So we need to be able to, and condensate, spill capture, filtration. So these are criteria that we put together to assess potential portable compressors. So that's where we're at with that. And so we're hoping to continue that effort. And then I wanted to go over a little bit the personnel. We typically, so if we're on one of the larger scale cruises where we're like that one on Thompson, and the picture shows the deck plan, where we typically have two geophysical engineers on opposite watches, technicians on opposite watches. We've been successful with the rental compressors of having a single mechanic or someone in that role during a day watch to assist. And then the engineers and technicians are also maintaining these, the compressors. And then, yeah, baseline minimum 3 PSOs. That's going to vary based on the project. So that is all I had today, if you have any questions.
Great, thanks, Lee. There's a question in the chat asking if there are any UMNOLS vessels that still have built-in compressors.
Just the length, Seth.
Yes.
Yeah,
Hi,
so
Hi, Lee.
I could talk a little bit about that. So starting in 2014, there were compressors on Melville, Revell, and Thompson. Thompson and Revell, those were removed at the midlife refit, and then Melville left the fleet. So there's no longer only Langseth has compressors now. So that has been an issue.
And for the Antarctic work, isn't the Palmer still has compressors?
Yeah.
Oh, so yes, yep.
Yeah.
But then yep, that is true.
So the following question would be that if we need to rent those compressors, 2 to 4 compressors, what's the footprint on deck? Is global ocean class handle that, or smaller vessel?
It's going to depend on the survey, how it's designed. So how much air do you need? What is the source, and how what is the rep rate? So that's going to vary on the
Okay.
which ship you. which ship you use.
Okay. So, Jenny, do you remember when the USGS did the matrix survey? Do you know which ship you used for that?
We used the no, I can't remember.
It was
the Sharp, right?
Sharp.
Yeah,
Okay.
the huge Sharp.
Okay. They're all getting confused, but yeah, we used the Sharp, and
Okay.
that was 4 210
Four.
GI guns,
Okay.
and I forget exactly how they were built, but we did size it so we could shoot them all at full capacity, and we had
Wow.
four of those start compressors on board, and they kept up just barely. And it was enough that if one went down, the other 3 could kind of hold on while we got that one sorted out. So,
Oh, wow.
so yeah, and they're about a 5 foot by 8 foot footprint, you know, and about 5 or 6 feet high. I think they're not a full container or anything. So
Yeah. And then 4 of them. Or that's
we had 4. We had 4 on the Sharp. Yeah.
okay. Wow. Thank you.
And
Yeah, and if you step down to a slightly smaller source system, then obviously you can step down on the compressor side fairly significantly. There are also, it turns out, boats out there with significant amount of dive compressor capability on them that you can supplement a seismic compressor system. So you can actually daisy chain these things together in some interesting ways, especially if you have some way to store some air to keep up. But not on the bigger systems. When you get to the multi-GIs, you have to have these bigger compressors.
Yeah, I'll make one comment. Working in the commercial environment sometimes, that the rental rates can be entirely dependent on the current other activity going on in industry. And I've been gouged very badly in the past. It would really make sense to have some stable compression that was available at fixed cost or reasonable increasing cost through time, because I've seen that eat up more than a third of the entire survey budget. I see Anne's got her hand up, so let's see what she has on her mind.
Yes, so I'm a little confused. Let's say that I want to write a NSF MGNG proposal. So, and to do like a high-res seismic survey. So I contact Lee at Scripps, and he's gonna give me like what he has, but then I want more. I want more air gun or more streamer. So then the next step would be maybe to contact either UTIG or USGS. But my understanding is like you don't provide any budget in the proposal for the Scripps part, but then it seems that for UTIG, you have like a daily cost. So should I add in the proposal like a budget for UTIG part? Or
so this is
what's needing in the proposal.
This is exactly a great question, and why we wanted to talk later in the session when we get to the answer to the questionnaire. We wanted to talk about the idea of having a high-res 3D organization of some form to help with exactly these questions, how we can make this easier on people. But right now, your answer is yes. If you wanted to use TIPS GI guns, you would need to put in money for the Bureau GI guns to supplement the Scripps GI guns for right now.
For USGS, I also need like a budget from USGS to be included.
So the USGS, we're still working on how we would be part of this, but right now there would have to be a USGS scientist collaborating with you on your project or somehow benefiting from the data that you were collecting in order for us to be involved because of our weird federal government status. And in that case, your budget, we don't have day rates for all the equipment per se, but it might have to cover a technician, one of us coming with the equipment to run it. And so, you could budget for a person, but not necessarily for the equipment. But again, you couldn't probably, right now, the way things are, you couldn't use us unless you were working with a USGS scientist somehow.
You can just grab Ginny and Jared and drag them along with you.
You'd love to. Yes.
You guys have all dragged me somewhere.
But if a PI did reach out to me in that regard, we are willing to rent equipment, things like that. But that would have to be described in the proposal because it would be above what NSF would expect for costs that come out of Oceanographic Technical Services. But yeah, I've been willing to go out and broker some of that too if we don't have the equipment that someone needs. But it's certainly an issue.
Let me jump in and just say we'll have hopefully some time later. I want to get to the two remaining. We're about 10 minutes behind, so get to the two remaining technical summaries, and then we'll have some discussion where I think, Anne, that question brings up all kinds of issues, right? And how it's such a hybrid of everything. So, okay, so John Hopper's next. He's going to talk about the Danish portable system.
Okay, thank you. Let me get sharing started. Good. And hang on, I should start from the beginning, I think. Okay, so hopefully you can see my screen okay. Just shout if you can't. So I was asked to summarize what we have in the Danish system, and I'm presenting this on behalf of the small but active Danish marine geoscience community. So this is not just, I'm not the only one who put in input into this presentation. Let's kill this and that. So what we have in our pool, we have containerized portable seismic reflection equipment. We have a variety of receiver and source arrays. So we have a large streamer winch that can tow a 1,200 meter streamer, of which 1,000 meters is active at 6¼ meter spacings. We have a 600 meters streamer, also at 6¼ meter spacing. And we have a 75 meter streamer that's configured at 3.125 meters. And I tried to clarify with pair, we do have some other streamers that have been built at 1.56 meters, but I'm not sure what the status of those are. So for high resolution work, we do have some even shorter group spacings available. And we also have at the University of Aarhus a P cable system for 8 cables, and it's much smaller than what Tip just described, because it's designed for towing off of smaller vessels, and it's suitable for towing cables that are 1 to 6 meters long. For source arrays, we have 4 520 cubic inch G guns. We have a variety of different G and GI guns, 3 250 cubic inch G guns. These can all be clustered and built in different ways. We have a variety of GI guns, a number of sleeve guns, and we also have some sparker systems. I should also mention that the equipment is a mixed bag in terms of ownership. Some of it is owned jointly by the University of Aarhus and ourselves. Other equipment is owned separately by either GAUS or Aarhus University. But you should know that in terms of using anything in the seismic pool, we have recently signed a formal cooperation agreement with the University of Aarhus so that everything that's available is managed in a shared pool, including technician support. I thought I'd show you just a few pictures of what things look like. So we have, for air sources, we have 2 Hamworthy compressors. That's shown up here on the left. It's shown here in this picture as a white container, but it has since been painted blue. So in some of the examples I'll show you of the equipment in use on different vessels, it'll be a blue container. We also have 2 Bauer compressors. They're a little bit less capacity. And what we often do for a bigger program is use both compressors together. And then we have some small hand winches to feed the umbilical out to the gun arrays, depending on the configuration and the setup. This is the streamer winch. Again, it can hold up to 1,200 meters of streamer. We currently have 160 channel active 1,000 meter streamer section, which is the largest that can be put on it. You can also see that there's some other equipment on here, including this extra winch, this was designed for working in the Arctic. So this orange winch also can provide air gun, the umbilical to the air guns, and it can feed the air system as well. And I'll show you how this works in another program where we deployed from the Odin. And the idea behind this arrangement is that there's only a single tow point for both the air guns and the streamer. So the streamer will actually plug in to this orange cable, which then comes into both the compressors and the recording container. And we have a recording container. So this is where all the recording takes place, obviously. This is it installed on the Odin. All of the equipment is rack mounted, so it is not necessary to use the recording container on a smaller ship. All of these things can be packed up and installed in a wet lab or any other lab facility on a ship. We have, if you are working on a bigger ship, we also have a workshop container, and that allows pair to work on the guns or on the other things. So this is just a small cluster with two 520 cubic inch air guns. I should also mention that we have seismic refraction capabilities, not through the University of Aarhus or Geus, but through a consortium called the DanSeis Consortium. And this is a national center for seismic instrumentation on land at sea here in Denmark. It's currently managed by the University of Copenhagen, but it will soon be transferred to Aarhus University. And in terms of technical support, it's all the same. The only difference is that the DanSeis Consortium involves not just Aarhus and Geus, but also the Danish Technical University and the University of Copenhagen. And we have 16 broadband ocean bottom seismometers. They can record continuously for up to 14 months. They're quite heavy, so they are a challenge to deploy and recover. And then we also have 21 short period Searsel micro orbs. These are quite a bit smaller, as you can see, 36 kilograms. And those can record up to 24 days at 500 hertz. And we've also recently finished outfitting a workshop and storage container for the OBS pool, which is shown over here on the right. So just some experiments that have been done with our equipment. So in 2015, Donna Shillington had an NSF project where she used some of our equipment, not all of it, but some of it. So this was on Lake Malawi on a barge. So I don't know if you can see this. So the Bauer compressor is this orange container over here. The Hamworthy compressor is this white rusty thing, which has since been painted blue. And then there's the recording container has been installed here. And then there's a storage container and a workshop container. We can also go to much smaller things. So over here on the right, this was a small GI gun with a 100 meter streamer that was done off the coast of Greenland off of a small fishing trawler. So there was only the compressor container was actually put onto the vessel, and everything else was done by hand from the deck space. And then this is the P cable setup. So this is a smaller system. This is how it's installed on a small 30-meter vessel that the University of Aarhus operates. And this just shows the cross cable winch container. There's a compressor behind here that you don't see. And then the paravanes and everything can be deployed from the A-frame off the back of the ship. And so here on the left, you can see using our system in the Arctic Ocean. So this is deploying the ice configuration from the icebreaker Odin in 2016. You can see that the streamer has already been deployed and is going out to the back. This shim protects the streamer as it goes out in the water because this has a dual setup. All this equipment you see down here is for gravity coring. So everything has to go over the gravity coring system and out into the water through this little shim here. The streamer cable then plugs into the umbilical that will eventually support the air gun. So you can see that the streamer is plugged into here, which comes up into here, and the air gun is being suspended from here and will be towed just below this. And then this second shim will go into place here to pay out the rest of the umbilical for the system. And this is an advantage for working in the ice because there's nothing on the surface. Obviously, you can't have any kind of buoys on the surface. And it also gives you a single tow point. So it helps protect the equipment behind the ship because you only have to worry about one tow point. And finally, here's a high resolution experiment we did in 2019 on a new Danish patrol vessel. This was to support the Baffin Bay IODP proposal. And this was a little different setup because this was gravity coring plus the high resolution seismic. So you can see the streamer is on a hand winch over here. It was just the 75-meter streamer that we used. The guns were deployed from a little hand winch over on this side. This is the Hamworthy compressor. And then we had a storage and a workshop container. And then we had a lab container that we, because the coring group wanted to sample in real time, we combined our recording equipment into a lab container that had some wet lab facilities that they could use. So this doubled as both the recording container and the container for working on the coring, which was deployed off the side with this portable A-frame system. Just some quick data examples. So on that Baffin Bay cruise, this is a commercial seismic data set collected by TGS in 2010. And this is what we were able to collect with a small GI gun, 90 cubic inch GI gun with 24 channel 75-meter streamer and a 4-second shooting interval. And you can see obviously that there's quite a bit better resolution in the high res, even though it's a very challenging area to work in because of the hard sea bottom and the heavily scoured seabed, which scatters a lot of energy. This helped us site because this is a gas prone area, having this high resolution data around the drilling sites actually helped us site optimal places for the IODP drilling that would also keep the safety committee happy. And then this is just an example that Katrina gave me of the P cable system we have. I don't know if you can read this. This is 100 milliseconds here. Some upcoming collaborations. So we have a project coming up using our big system in May with the Celtic Explorer. That's a collaboration with Stephen Jones and Brian O'Reilly. We'll be supporting Bernie Coakley's Chukchi Borderlands project on Sikuliaq in August, September this year. And then next year, we plan to look into using the Danish patrol vessel again to collect data in Southeast Greenland. But in that case, we will try to use our bigger system along with the OBSs. So we'll have the big streamer winch, both compressors and OBSs for that program. So I thought I would just give you some key contact people in Denmark if you're interested in setting up any sort of collaborations or partnerships to use this equipment. These are some of the key people involved. There's Per Trienhammer, our engineer, who has built and designed a lot of our Arctic equipment. Ola Rune Clausen, who's a professor at the University of Aarhus, Katrina Juel Andresen, myself, obviously at GAZE, Thomas Funk at GAZE, Paul Knutz. So with that, I'll happily entertain questions.
Okay, thanks, John. We are a little behind schedule, but if there's some quick questions for John, we have just a bit of time.
Guess not.
Okay. Why don't we just do the last system summary here from Sean Higgins and the Lamont system, and then we can take maybe a very short break and then have our discussion. Sean, if you're speaking, we're not hearing you.
No, I've just got unmuted.
Oh, okay.
So I just wanted to brief out, catch us up on time here. You know, we operate the Langseth here at Lamont. We have operated, you know, smaller systems with our compressors on board. I'm just going to emphasize a few other things. One of the biggest things we've been involved in is answering questions like Ann Bassell asked in terms of different combinations of things. We've done a lot of consulting in the background to help people spec systems for the projects that they have. We get a lot of questions from people. And I would say one of the most important aspects, I think, to all these organizations that have presented is a lot of technical staff that has lots of experience. And our technical team here is no different. We've got 8 other technicians that have decades each of experience with different types of systems and equipment. Jesus Gayton is our new technical services manager, who was formerly with NCS Subsea P Cable in Houston for the last 15 years, brings a wealth of experience with him as well. So I would encourage, you know, anybody on this to reach out to, you know, any of the folks on these calls. There's lots of experience at all these facilities. That's just as important as the systems. I'll bring up a little bit just to highlight and kill 2 birds with 1 stone. These are the type of agreements that we've had. We've typically never charged for use of the systems we've loaned out over the years. We've had 4 GI guns here. They're 210 Sersal GIs. This was a letter from the USGS as an example for the use of these to use on one of their cruises. Jennifer McKee, who's on this, was part of this project, and it was all the different spares and pieces that they might need and a lot of the hardware and stuff. So sometimes all the spares are just as important as the actual equipment. And basically it just, whether it's insured by the USGS or the government, typically only ask that, you know, equipment is covered either by insurance or whatever in the event that anything happens to it. I don't think we've ever had any issues with it other than maybe some small spares cost. So, you know, like I say, these guns have been here for quite a while. And typically we've loaned them out to various entities over the year, but just as an example of how to overcome some of these obstacles and to help supplement science. But there's a lot of these things that go on in the background between the entities that are represented here. We have other planning tools that can be brought to bear on some of this for plotting out. Things like ServOp that can plan out a survey and help you with timing and things like that. These are things that can be used onshore and anywhere. We have other tools that can potentially be deployed, technicians that can travel with these. This was an example of a hybrid 3D P cable system we did off the Langseth. This is a 24 streamer jumbo P cable, one of the largest arrays that they had put together through Geometrics that we leased. And with it, we also ran a 3-kilometer long cable underneath of our regular Sersal solid cable for velocity control. And this was off the coast of New Jersey here about 5 or 6 years ago. So we have done sort of jumbo scale, high res, if you will. But I would say in the terms of what this meeting is about, I think it's as much about, you know, sort of all the machinations you have to go through, the different platforms, the different requirements that you're trying to meet. And it's often difficult to have some of those all in one place. But that's what we're contemplating, is better ways to share this so we can take advantage of a lot of the assets that are out there. But with that, I will stop and we'll leave this for this afternoon's discussion.
Excellent. Thanks, Sean. Any points of clarification or questions for Sean Higgins before we take a short bio break? Okay. All right, why don't we just, it's about 3:18. Why don't we just take about a 5-minute break here, just to come back refreshed and ready to talk about this, how we're going to move forward. Okay, thanks. All right, so hopefully everybody's back, and we wanted to spend the next, I guess 45 minutes or so, now more like half an hour, talking about these different elements of the survey, and maybe talk a little bit about the possibility for a center. And so I guess, Sean, we were going to start with you, kind of summarizing a little bit on the experience, and then Sean Higgins was going to talk a little bit about obstacles. I could talk a little bit about ideas on the center, but I think we want to focus a lot on conversation. So let's make the most use of our time as possible before we wrap up at 5.
Sounds good. So I'm just going to quickly tip as soon as you, I'll share my PowerPoint here. That is nothing more than the 29 people at the time that I downloaded these and their response. Hopefully, I see we've had ranging numbers up to 35. So hopefully anybody who's not done the survey, it'd be great if they could get their comments in as well. But this is just basically, who's on the who responded, and you can see that we're interestingly about a quarter each between students, recent/early career, mid-career, and senior, which is great. And there's just a couple other things here. So this is, have you undertaken a high-res experiment? It looks like 2/3, 1/3, roughly speaking. And then this is, if you have, what did you use? And you can see it's really all over the map, which is kind of part of, I think, the argument for needs for coordination, because there is definitely not a one-size-fits-all story here. And I suspect that you can see it both in the 2D and the 3D, and you can see it, in the different types of sources, the use of CHIRP, as well as different kinds of boomer sparkers, geoguns, and guns. Okay, and then also, does anybody own anything? Looks like, a little bit close to half, something like that. And it could be, I would actually be curious, we didn't subdivide this, but it might be interesting for the conversation. How many people maybe just own a CHIRP but don't own some of the seismic, or vice versa, things like that. And then it looks to me, if you own something, you have somebody that can help you operate it from the looks of it. Basically, those percentages are pretty much exactly the same. So that probably makes sense. And if not owned, how did you get them? And this was pretty interesting, so it looks like, we see, people were leasing, borrowing, purchasing, and so on, right? And I'm not quite, I think some dialogue here would be worth having as to how people would find ways to access, and whether that can be improved with a center or some other method. Okay, so that's it for those. Oh, no, it's not. Okay, there we go. Okay, and then if you own the components, what do you own? And this is sort of the same, somewhat of the same list that we saw a minute ago. You can see the percentages drop on some things. So there are some things that fewer people own and more people use, would be another way to look at it. So for instance, 60% of the people used a towed CHIRP, and 45% of the people own a towed CHIRP. So some people are clearly, 3D, those who have used it is larger number than those who own it, which also makes sense. And then if you do own this, is it made available? This is a really important thing. So, informal loans are pretty low compared to either a collaboration kind of framework, a leasing kind of framework, or not available. So, this is that conversation. And then if not available, it would be very interesting to figure out ways in which things can be made available if we can figure out the right policies. Okay, and then not surprisingly, many more people have the ability to process the data than own the equipment or have shot their own data. So I found that useful to know. But fewer people who have access to it have actually used it. So. And then seismic interpretation and processing seem to have almost the same percentages as to who has licenses. And the people who've actually used it have almost the same percentages as the people who actually have licenses. So I think that's it for these. Yep, it is. Okay, so I'm going to stop sharing and turn it into a dialogue now, hopefully. And I guess we'd like to just have anybody who's got some thoughts they want to bring up into the chat. any questions they want to ask of sort of our panel, if you will. Emily wrote, not everyone. That's right. So 17% of people did not have seismic processing software. That's right. And slightly less than, or close to that, did not have seismic interpretation software either.
Yeah. Hey, Sean, and I was actually sorry, that was not that clear. I typed that in quickly, but I was actually referring to support staff. That was myself. So it may be that I submitted my responses late, as it did seem like your numbers were very similar there. I see but I would be interested to know, like, for the components, for the academic institutions, especially where you might have one component, I wouldn't be surprised if there are folks out there who don't have a technical team to kind of help them with that. So anyway, I don't know. That
yeah, and I know personally of some of my former students, for instance, who have equipment that don't have technical.
Right.
Yeah.
I think, Sean, on the software side, there's two things that come to my mind. One is sometimes you have institutional licenses, and sometimes they're actually more like commercial licenses. So I interact with both examples, and obviously you can get sometimes bigger, if you have a big institution, it's easier to get an institutional license perhaps. There are cases where I've gone to commercial licenses, and there are fees for maintenance that you want to maintain, and that gets harder and harder to build into proposals.
Yeah. So I guess the question maybe to the broader community, maybe Foster, is more sharing of expertise and more sharing of equipment wanted, to kind of fill in the gap for the other third of the people who've not been able to do one of these high-res surveys, in effect.
Yeah, and there's a comment here, Sean, from Tim Hinstock. He goes, the fair proportion of people are using boomer and sparkers, but a lot of the main equipment mentioned by the presenters earlier was with larger GI guns, probably except for the Usgs, which uses those quite a bit, and
right,
perhaps John's group as well. And I think this is a part of it that we're missing, is that there are people with these smaller systems, and the people we're hoping to hear from is that there is a lot of this equipment around of the smaller systems that some of these larger groups probably aren't aware of, and that's what we're kind of trying to draw out here is,
that's right,
is it difficult for them to do their science and stuff and get more people involved in using these things.
Yep. We've also had examples where we've used our streamer or our components with a sparker. So we don't own a sparker, but we've done surveys where we brought our acquisition system along and used sparker sources.
Yeah, we've done exactly the same. We've used the Texas A&M sparker on a USGS project in Alaska, for instance, with our receiving systems.
And I should mention the USGS, the majority of our operations high-res are sparkers, and a lot of that is predominantly due to the regulatory issues with air guns. And so we operate under a different framework by NIMS and under a CADEX from federal waters. And we have sources that are categorized based on their review of these sources. And sparkers don't require the as an involved regulatory process as if you were to use air guns, although that might be changing actually this year, which is what Jenny alluded to, at least for shallow water.
Yeah, we've actually had a CADEX through the BOEM that included small air guns and sparkers, and now that's changing the other way.
Yeah.
Yeah. I see several comments. Yeah, go ahead.
Beatrice McNally brought up the issue that MSROC, the Marine Seismic Research Oversight Committee, had started in on this, and actually this is a continuation, if you will, of that effort. Pat Hart, who was former chair, was involved here as a convener, and that's part of the reason we wanted to pick up this thread. It didn't really get finished. This has been something I think that talked with both Tip and a lot of us about, because this has been a subject of NSF interest and others to talk to this high-res community that makes up a fairly good proportion of the seismic work that gets done. And so much of it is happening somewhat formalized in some circles and ad hoc in others. but I think, you know, weren't fully successful with the committee efforts to develop that full inventory. And this is kind of another way of trying to embrace not just the inventory, but also the other obstacles and impediments to, you know, getting more people both into the field and access, and trying to kind of assess in our survey in some way those issues.
Yeah, and I think that having that inventory will help everybody, especially people that have just part of the equipment, to know where the other part might be so that it can be used. You know, creating an inventory of available rates and who to contact is somehow what is missing right now, and perhaps even preventing people from, you know, distributing this information and using it. So that was the idea, and I see that as an obstacle, for example.
Yep.
Yeah, but I think that the problem with building this database, because Sean Gullick and I were partly involved in that, is that what we have now is just a spreadsheet, right? And how useful is a spreadsheet that quickly becomes outdated as things move. So,
right.
So I think the way to make an inventory list work is to have UNOLs task somebody with creating a website or a system where people who have systems can go in, report what they have, put in to contact people.
Yeah.
And then there would be a simple place where everybody globally can go to find out what other people have. And I'm sure that the international users would be interested in that too, not only for to find out what's out there, but in terms of advertising our own equipment, because we're always looking for projects. Our biggest problem is that the equipment needs to get used in order to keep it running. And if we don't have projects and income coming in to help pay for it and to buy spare parts for the compressors, then things will fall apart. So we're always looking for people who are willing to use our equipment.
Yeah, and I would argue it's not equipment in some ways we're lacking in all areas. I mean, there's certainly gaps, and I think this can help identify, I think, where some of those gaps are. But I think it's also, there's a lot of expertise around, I think, of people that are willing to help those that maybe are just getting started or only have one piece. And I think this is meant to be also an advertisement that there is these other sources of equipment and expertise around, you know, so that both people and equipment, you know, can be brought into these things to, you know, do that. So I can jump in real quick and answer. Some of this feeds right into the obstacle part here, and I'll just touch on some quickly, but I think you can see these similar answers coming out of the obstacle part here.
Yeah, agreed. Yeah, and I think there's also there's a communication challenge, right? You know, just making sure that people know what's out there, know how to access it. And then there's the ease of proposing challenge that has already been raised. You know, there is a checkbox for the script system, you know, when you submit to NSF, but if you submit to, you know, but if you want something that's not in it, it's not clear how you do it. And then for many other agencies, there isn't an obvious way to link systems that are out there to the funding.
So just very briefly, you know, it's sort of looking at some of the obstacles that we discussed, and I'll get into presentation mode here. Ship time and funding are always obvious issues. Not trying to address all of those, obviously. Equipment access, ability to loan, would easier access help with new science ideas or education ideas? And would you propose new science if you knew about equipment access in advance of a proposal? And so just looking at these quickly is finding, you know, same answers really for, you know, funding and ship time. I mean, always a challenge to, you know, get good proposals and to get them funded. But then getting into is finding or having access to the appropriate equipment an obstacle. And again, I think we see the breakdown a little bit that we saw in the first set of questions where, you know, we have people that know where it is, we have people that have it, and then we got a whole third to half the people that this is an access issue. If you have existing equipment experience, would you make them available? And I think you see a more diverse set of answers here. Usgs talked about some of their obstacles of needing to be involved in the projects as it stands. And again, more of a split between, the people that, have equipment, think they have a way to loan it, and others they don't, or they can't. And I think that's, kind of consistent. But where we saw this all diverge is like, are you interested in carrying out these experiments for new science ideas and education of students for teaching methods? And this is where you see this big jump up to about 80% of the people surveyed, saying yes. I mean, this is, would you help? I mean, does it help to be able to do this? And I think likewise, would you design new experiments or proposals if you knew how and where you could get access to the appropriate equipment in advance? And I think, again, this large percentage jump, is sort of what we're trying to get at, is like we want to encourage more science coming out of this by making it more accessible, and that it's not as daunting for early career student projects, people in undergrad programs that want to introduce geophysics as part of curriculums to undergraduates. These are the communities we definitely, want to be able to reach and, have it happen, more easily. So I'll stop there. One aspect I can talk about separately. Here, at LDO, we also, Ann Bassell, who's on this call here, or has been, has done a lot of the acoustic modeling for almost all the US projects that involved air guns as part of her actions as a chief scientist here in our office at OMO. But, someone, I think it was Simon, had asked about, regulatory things, largely for the low energy stuff, or especially for sparkers and things, the PAM's not required, in other issues there. With the rest, we work with NSF to do the appropriate IHAs and EAs with National Marine Fisheries or other entities, U.S. Fish and Wildlife, or many other agencies and stuff that come into, especially coastal waters. Right now, for example, I think for the coastal waters, even for the Langseth or anything else, there's quite a bit of regulatory overhead to do that, which you can avoid with some of the smaller sources if you don't need, the larger ones. But that's always, always a facet here. But I think in terms of, we've not really ever not gotten a permit in most instances. So I don't think that should be really the limitation, for people proposing the science they want to do.
Yeah, and there's been a lot of movement in that area, a lot of coordination, especially through the USGS and with NSF on the low energy sources that are starting to streamline things a lot. And I think it's probably going to improve in the next couple of years, or continue to improve, I would say, where it's just much clearer what the exclusion zones need to be and things like that. What seems to be really variable, depending on who you're working with and what CADX you fall under, and whether you're in state waters or federal waters, ends up being how the PSOs have to be handled. So in some state waters, you can train people on the science crew as PSOs as long as that's their whole job. When
PSO, Sean?
Yeah, a protected species observer. Sorry. Well, it used to be called marine mammal observer, but now because of things like turtles and so on, the term is usually protected species observer. And there are now online classes and things people can take and become certified and send it up through NIMS and get officially certified. And so that's a new avenue that didn't exist before. It used to be viewed as something that if you were on the science party, you could not do it. And now in some places that's allowed, as long as you're not trying to also be on watch standing duty for something else. And you can't go above a certain number of hours in a day. So there's an easing to the opportunities, I guess, is what I'm trying to say. The obstacle's still there, but not as horrible. If I can say.
Now, there's definitely been a movement by NIMS, I think, because of BOEM and trying to merge industry rules and also rules followed by the academic side to try to start standardizing some of this. So there is, I think, some new rulings coming out on low energy versus high energy by this summer. It's kind of been delayed, but I think it's going to help, I think, clarify some of these boundaries.
Yep.
Even further. But a lot of the efforts to calibrate, the Carolyn Rappel and others led the effort, I think, on the East Coast to calibrate a lot of the sparkers and all these other sources and stuff, has gone in. Also, Larry Mayer's effort with multi-beams and other sonars has helped provide the data that some of the regulatory agencies need.
Yeah. Simon, your hands up.
I'd just comment first to thank the USGS in the past for providing marine mammal observer training to me and students, for letting us sit in with them. That was incredibly useful. Our biggest problem with the Cal State waters, where we've had really no movement on being able to use anything, any air gun source at all, any compressed air. We can use a fish finder of as high energy as we like, as long as our intent is to go out and kill the fish. But we're not allowed to use any air gun source, however small, if our intent is to look below the sea bottom. And I've heard of no progress on that. All these new developments, I suspect, will not supersede state regulations.
No, I think California remains difficult.
Yeah, as far as I know, and I'm not in charge of it anymore, thank God, but California state lands, we have streamlined how we get our permits to do work in California state lands, but I don't think any of that, I mean, we have to get a permit to run a jet ski with a single beam, you know, thing on it. It's ridiculous. So it's none of that, but what can be put in the water hasn't changed. We are working with them, and they seem a little like they want to work with us, so we have a good relationship with them, which is new, but yeah, they haven't, I don't think they've budged on pneumatic anything.
And my aspirational hope would be that USGS, working with Cal State Waters, would be able to show them calibrations of specific sources from the specific manufacturers that they would then permit as a specific source. Not necessarily the USGS owned one, but other clones of that, for example.
And we did, Jared, I wasn't on this trip, but the USGS did go do a sound source verification. We've done a couple different cruises on the East Coast. We went to a swamp in Florida and shot our guns off. We're doing another Sparker test next month out here, all with that all in mind, that we're going to put this in the water. We're going to listen to all these different ways, figure out where everything's going, and see if we can convince some of the regulators that that the rules can be made more applicable and not just a blanket no-go. So I think that that is being worked on, and I can't, Pat Hart would tell you about it all day long. I don't know all the very specifics.
Yeah, so Pat and I are actually going to be out out next month. We're doing this particularly for sparkers in shallow water, because there's concern with, are we dealing with a kind of spherical divergence in shallow water, or are we dealing with a cylindrical because sparker is an omnidirectional source, and preliminary data doesn't have us very hopeful that we'll be able to keep sparkers in kind of that tier 4 category that we operate under our category exclusion. And then this is the information that'll be given to NIMS. So we've designed a test that we're going to go out with a 2-boat operation, calibrated phones, shoot various sparkers at various powers at various depths, and do the distances and see when do we get that dB fall off. Basically, that is what they're looking for. So we should have that information by the end of April, hopefully.
So one thing I would like to touch on, though, outside of the regulatory stuff, is to come back to those last couple questions about people that said if they had access or knew of access ahead of a proposal, they'd be more interested in, putting in a proposal or things there. Anybody that responded positively to that, I'd like to, be willing to share their thoughts on that, because I think these are the kind of things that NSF really wants to hear. It's like, is better access going to get more science done? And I think that's one of the things we're after with this center idea, or whatever shape it takes. There's no predetermined outcome, but it'd be good to hear from people that would, think this would help.
And maybe that's a good segue to this last section. I'll just go through some of the bits on the center. Yeah. Somehow I lost this, but do you see it?
Yes.
Okay. So what you'll see here is that blue is generally support for this concept, and there's a lot of blue in these responses. But this first one was about, do you think there should be a pool of community resources? And this is a large number, 80%, which tells me that a lot of the people that have the equipment are answering yes to that, which is a good sign. That means that they know enough about their own equipment that they'd be willing to put it into a pool. It does present some challenges, as has been noted, and then we just talked about permitting, which was one of the responses. Do you think if the center formed, you know, should it consult with entities to determine what the best, you know, equipment might be for achieving their scientific aim? And pretty much undoubtedly yes. You know, how sometimes the scientists know what they want to study, but they might not know the exact best tool that's available for them to get what they want. So consulting on that would be great. And then a unanimous decision that if the center were formed, center like that were formed, should coordination and facilitation of the equipment be part of that role? And I think that's the core of what we're getting at here, is that, you know, everyone is basically 32 people are saying, yeah, you know, coordinating the use of this equipment is really maybe the way forward here. And then 27 was about if such a center were formed, should education and assistance in processing high-res data be part of the role? And again, you see a lot of blue there, meaning, yeah, they'd like, you know, to incorporate those components as possible. And that's really an expansion beyond what exists today, which is mostly just equipment coordination at an informal, or, you know, it's formalized, but it's a very, you know, as Sean has mentioned, it's very patchy in terms of how that communication occurs. So people would like support with other things beyond just knowing about the equipment and sharing it. How about technical support? I think, you know, that's part and parcel of the whole concept that if equipment's going to become available, they're going to need to be support. This probably brings in a lot of researchers who are at smaller institutions that might not have the ability to have technical support on these kinds of things, and they're not going to touch this equipment unless they get support in using it. And then are you interested in learning more about a facility? Sure, that was pretty overwhelmingly yes, and further discussion as well. So I would just encourage anyone who answered in the positive on this 87.5% to get in touch and consider how we might go forward here. There's been a lot of discussions at, you know, basically different levels, different kinds of meetings. Marine Seismic, MSROC has had discussions. There have been workshops. There's been a lot of things out there, but I don't think we've ever collated the data quite like this to really understand this issue. So we did try and put a center concept forward in the past. That was, let me see if I can just show you that real briefly. There was a sense that, back up here, sorry for the delay. So there was a sense here that you know, in 2019, there was an attempt to do a mid-scale research infrastructure proposal that had lots of institutions. Many of the participants in today's meeting will remember that. It was about a $20 million proposal, which ended up being too lean to actually go forward. But it was a multi-user infrastructure consortium dedicated to this topic. So there was a full proposal submitted on this, not just a pre-proposal. And we brought up that conversation with NSF again in 2021 and tried to understand a little bit better whether we should go back to this same kind of mechanism or vehicle for funding this. And really the response was what generated a lot of conversation about having this forum. You know, the response was, well, we're not really sure who the user community for this is, and would they really use the equipment if we pooled it, and what kind of investigations are we talking about, and what costs, and all of that. So I think for me, the real question here is, where do we go from here? So I'd love to hear people's comments on that, and I'll just stop sharing and listen now.
Go ahead, John.
A quick comment. What really kind of surprised me was that question 25, if such a center or facility were to be formed, should consultation on best seismic tools for the job be part of this role? 96.9% said yes. And to be honest, that surprised me, because this group of people are people who know something about seismic acquisitions. So we know what tools we need for a given size of a target or a target depth or whatever it is. We know, do we need a sparker system? Do we need a big air gun? But so it really strikes me as interesting that this group sees that as very valuable. And that's something I think to take to NSF, because outside of this group, if you're working with paleoceanographers and people who don't understand seismic acquisition, it's really surprising sometimes how little they understand about what needs to be done and how to design an experiment to image what they're trying to get to. So
Yeah.
I think
Thanks
that's
for that
something-
comment. My interpretation was that also had a lot to do with availability of technology as much as advice on which technology is generalized. But Lee, you had a comment.
Yeah, as part of that, I mean, one of my concerns when we say these different pieces of equipment are here and there is when you're going to do a project, who's going to be the integrator? You know, who's going to take on that role of integrating it? And I think that's where, having worked with a number of different PIs, some that have experience with surveys and some that, and many who do not, that's always like, how do I navigate? I know where these pieces I need are, but how's all that going to happen?
Yeah, and I would say, John, it just, the questions that have come to us, you have people that have a lot of experience with one thing. You have a lot of people that have worked with sparkers because that's what their advisor taught them. They really don't know what these other tools could do for them because they've never had the opportunity, you know, and even on the Langsat, there's a lot of people that come out there assuming, okay, you know, bigger is better, this is this is that. And I think this is where the technical teams that exist for a lot of these can help say, you know, you could get just as good if you drop the streamer down here, or you did the air guns like this, or whatever, you know, people that have seen different configurations. I think while there is experience, it's often people's diverse experience is relatively rare because of systems they have and they don't use other systems.
Yeah.
Emily's got her hand up.
To bring this up to NSF so they understand that even experts in the field need this.
Yeah.
Emily, you're muted, but.
Sure. Oh, yeah, no, that's okay. Thanks. Yeah, I had maybe just two hopefully quick comments. One, I think somewhere along our dialogue, there's been mention of sort of training and education. And I'm sure I'm not the only one in this group, but I have a little bit of experience thinking about how to incorporate students like easily with these kind of high-res surveys. So not necessarily just bringing them along on a big, expensive funded experiment, but like actually incorporating tools into classroom activities. And so I guess I was just going to mention that I think that the CHIRP systems are like great resources for that, and that I think a smaller technical team of people can use them, and they take just less mobilization and configuration. And so just that's my perspective, is that you know, even processing the data as kind of a single channel data set, it's manageable to sort of work with the seismic reflection profile from a CHIRP system. So I was just going to register that quick comment. And then one other quick thing, just in the context of thinking about how to make it easier for people who don't necessarily have these systems to propose to use them. I think, you know, just other considerations to be made, you know, even doing something like starting a listserv where if there are people that have questions, they could sort of broadcast it to this same group maybe that's here, and folks who have time and capacity can help answer questions like who has a high-res streamer, or, you know, I'm looking for a 512i, like, does anybody have one of those that's not being used? Could be helpful, and considering sort of the full costs that are needed to propose these systems in the proposal writing process. So, like, you know, not only a rental rate and to pay technician salaries if they're included, but shipping, you know, like that's something that it takes a lot of legwork, and for somebody who doesn't really know what they're getting into, it can be really challenging to, you know, they're working on a proposal deadline and they probably procrastinated and becoming overwhelmed thinking about how to budget for these things, I think is definitely, at least I think, probably a barrier for some. So I think it's part of what makes, I think, the script system really great, in that Lee and his group is sort of doing a lot of that legwork, I think, right now, but extending that to maybe more of these systems would be good. So thanks.
Yeah, I mean, I would say, I mean, part of this is, Jack, you know, trying to, you know, is to pull some of this out of the shadows, because Lee's talking with Jenny and Jared and Pat and us, and we're juggling equipment in the background so people don't have to see some of this complication. I mean, we make calls down to Houston to make arrangements for people to borrow some equipment from people we know. And this is something I tried to explain to Candace and others at NSF, is there's so much that's not being seen, or even it's not in anybody's job description to be doing these things, but I mean, it's this is how the science is happening, is through the goodwill and cooperation of people that are excited to see the science done. So hoping that this deserves more attention, I think, than what it's gotten. The compressors that Lee's putting in for are one example, but it's filling in some gaps that we have. But there are systems around like John's and other people that they've been combining that represent real resources to the community that I don't think everybody knows about, and stuff. So I think ways that we can figure out to highlight, whether it's a web page that people can populate, or whether it's a UNOLS supported thing or some other mechanism. I think I would just like to see this more discussed out in the open, because it's just, to me, it's been one of these things I've watched go on for 10 years. I just shake my head with the amount of time we spend doing it with no really part of our mission being defined in this way.
I don't know how to raise my hand in Zoom, so I'm just going to raise it. Another thing that we haven't really talked about, I think it's really easy to talk about putting an inventory or making a web page of a whole list of equipment, but we're not talking about the people that go with that, either to help you choose which equipment you need, like you were talking about, John,
Yeah.
or to, like a lot of, you're not just going to, ship a GI gun to an undergraduate and tell them good luck, So I feel like that's a piece of the puzzle that's harder to, it's easier for us all to send a list of inventory, to put it on, web page or whatever, and we could do that. But I think we have to talk about the people part. And I think that's what's going to be next. And it's the harder part, to be honest.
No, it's like I say, that's why I tried to emphasize the people early on. I mean, and it's the people at all these institutions. And I think it all goes hand in hand, the maintenance, the technical part, all the same things it does for any other system you're trying to maintain. But there is a lot of technical expertise that's the real driver behind this. I mean, it's the people on this call that are really pulling together all those pieces and understand the things they have, and stuff. So I would really readily agree.
Yep. So,
Okay.
So
and if I could just, what do I want to say? A long time ago, last century, I ran the Pascal Instrument Center, and at the time made efforts to try and get people who owned instruments to share information so that they could at some level be folded in to the national Pascal instrumentation facility, and it was never terribly successful. I know that within, oh, Beatrice, excellent. I didn't know you were still in that role. Wonderful. For those who didn't see the chat flash up, Beatrice is the chair of the Pascal Standing Committee. I know that Pascal has been involved in many discussions about whether they should be involved in any sources as well as receivers, and I have no idea the status of that right now. It is possible that Pascal or IRIS might see themselves as willing to host a virtual center on their website, which might be as much as tasking, it says that UNOLS might do this, but trying to think where the communities overlap, it might be the Pascal type individuals as well, and to expand a website to include links to other sites or a spreadsheet. And I think the spreadsheet can go out of date, but it can still say last accessed on. And, so I think that Sean Gulick, I hope that UT might put up, it doesn't matter if the prices are out of date, as long as it says 2016, it still gives the brand new PI a sense of whether they're going to do this with their undergraduate teaching funds or whether they need a full NSF grant to go ahead.
So I can tell you that as somebody who uses both land and marine equipment, I have pushed that way of thinking into Pascal since 2009, and with no success. So at the same time, IRIS is has pulled out of the OBS equipment, and so I don't see this as and there is no interest in Pascal in investing in marine sources and receivers. That is, I can tell you flat out. So if there is an interest in the community that uses both equipment, marine and land, into doing this, obviously IRIS and the community should drive that effort, and IRIS and Pascal will listen, obviously, because it's a facility that responds to community input.
Right.
So, but so far, I've been one of the very few to request that, and so Pascal has already its end full, with land explosive and sources.
Yeah. So maybe either an existing NSF funded facility of some sort is the obvious place to begin a small scale virtual center, and that might be OBSIP because they have a fleet of receivers, and so it's not a big stretch to list other streamers and from there to list sources. Or scripts. Lee, I think you mentioned that you were funded as an NSF facility, not just as, did someone say that? I saw that one would click a box on an NSF grant and,
Yeah, it's not that formal. It's actually a specialized service under our Oceanographic Technical Services grant.
Right.
Yeah, Anne's got her hand up as well.
Yeah, I just wanted to comment from the perspective of a user of Lee's facility. I've used that facility 3 or 4 times in the last decade or so, and it's been quite easy to use. With that equipment, with the GI guns and the streamer and the recording system, you do need technical help coming out to sea, as opposed to a CHIRP system, which I once rented and put into Crater Lake and just drove and pick it up and didn't need any technical help for that. But it has worked quite well from my point of view. And Lee's group has taken care of the permitting, and we've gotten absolutely beautiful data. We do have data that we can compare. I think having some just some little flyers doing some actual comparisons between the Sparker system the USGS has, which is also great, but doesn't get quite the same penetration. We have data in the same places, so we could prepare a little comparison, but it has worked quite well from my point of view. It's been great, and I would hope to do it again. And also, I just wanted to make one other point. Masako Taminaga led an effort a few years ago to do a early career scientist training cruise on that, using that system, and that was designed not for marine seismology students, but rather for paleoclimate students, geodynamics, people who are interested in looking at the data. And I think that was quite successful. It was a lot of fun, and it's resulted in at least one published paper and several papers that are in press from various students who were involved and other early career scientists who were involved in the effort. So, when we were doing the evaluation of the program, say months after, we didn't have those successes to point to. It took a while, but 4 years out, I think it actually did have quite a bit of impact. And there's one of the paleoclimate students has a much better appreciation for the use of seismics, use data to plan a ODP proposal and to support an ODP proposal. So those data are being used quite widely. And I think the feedback we've gotten from the students has been quite good. So I really do want to thank Masako for having come up with the idea and having made that cruise happen.
But yeah, just before we get kicked out here, I just wanted to thank everybody for coming today, because I really appreciate everybody taking their time. But Casey, are we going to be, this will be ending very soon?
So it's technically it's supposed to end automatically. I don't know how long it gives us past this time. If I can, though, address one point that was made earlier about IRIS, the decision for the management of the OBSIP facility going away from the IRIS umbrella management of 3 institutional instrument centers was not a decision we made. So that was at NSF level. So just wanted to make that point that the transition from OBSIP to OBSIC was not an IRIS decision.
Thank you, Casey. Thanks, Casey. I'm gonna point that out too, but also thanks, Anne, bringing up that the great memory of our effort. So I want to go back to what Emily's point, the point Emily made a few minutes ago, that I personally think that one of the greatest success during that early career chief scientist training cruise on the Revel using the Scripps portable system was that we could have 2 seismology postdocs. They were the greatest mentors. So you Dan, Greg Mountain, and Mitch Lyle, extremely senior, very experienced seismology facility user, mentoring a postdoc, mentoring students, not necessarily experts in seismology. That whole stream, would love to see that's going to happen again, no matter which facility we're going to use, because that was a really good model to becoming a mentor, good training, and then also having, you know, numerous mentees whose background was so diverse. So I would like to give this as a hint to Emily.
Yeah,
if you're already.
Yeah, that's a very good point.
Yeah, no, and it was certainly part of our proposal, you know, to try to stir more educational opportunities as one way of addressing this, you know, for early career people and students to get them more experience. The other thing that I should mention, NSF, because a lot of this equipment is owned by other agencies. You have USGS, you have Bureau of Economic Geology, which is a lot of DOE funded facilities and things. They wanted to see those agencies have some skin in the game, if you will, too. So I think part of what we want coming out of this group is to also go back to those agencies in support of this, whether it becomes virtual or whatever, but to try to get, you know, this is happening across agencies for different reasons, everything from geohazards to other types of science. So I think making a case that this equipment can support a broad variety of the geosciences that support lots of different initiatives to try to broaden the support beyond NSF, I think is something that NSF wanted to, you know, try to extract out of this, you know, in addition. So, you know, because NSF in some ways has very little equipment, relatively speaking, you know, as part of this. A lot of this is owned other ways, you know, and stuff. So, but just wanted to get that point out there because that was something they brought up to us.
Yeah, that absolutely seemed to want some multi-agency cooperative center, which nobody knows how to do. So, Lee.
Yeah, just a couple things. I know with the, you know, we talked about the people, also with the compressors, I mean, they need to be used pretty frequently. If they just sit, they're not going to do very well. So having compressors that could fit multiple agency, that's the approach that we've taken with these compressors. That, you know, hopefully they could be, the cost could be could be taken by, you know, whoever is supporting the project, a cost center, as you've described. So that's the approach we've taken with those compressors, to have them do multiple research projects.
So we're about 15 minutes past when we said we'd end. I think obviously the conversation needs to continue. I'm not quite sure our best way to make this conversation continue. One option is, somebody mentioned creating an email list, which we could certainly try to do, or think about another mini workshop we could try to organize. Maybe we could all discuss what we think is going to be most effective, you know, offline or something.
Yeah, well, I think we'll, you know, we have everybody that's responded to the survey. We have the survey, we have the list of folks from the symposium. You know, we can certainly dig into the survey results, you know, further and produce, I think, something from that, you know, and distribute that. And then, but yeah, I think there's definitely follow-on discussion for those that are interested would be great.
Yeah, any final thoughts from anybody? Okay.
Thank you for organizing.
Yeah, thanks so much for everybody's
Yeah,
input.
thanks to
Thanks, Sam.
organizers. Good session. Thanks.